Rajendra, and in this particular video we are going to discuss about how we can containerize an application practically. In our last video we discussed the theoretical part, what is Docker architecture and all, but in this video we are going to see the how we can actually do it. Okay, we are going to see that practically. So I have one simple Python application. Let me just show you how it looks like. So this is a Python application. It's very simple. Uh, it is just using one Python Flask module which is used to create a web service. So it is just creating one web service which is running on port 8080. And if we try to access this application will simply return a message, hello from container world, right? So this application has to run this application we need couple of requirements, that we need some mini OS, and on top of that we need Python to be installed, and then this Flask module to be installed, right? So these are the three basic requirements we have. So as discussed in the previous video, if you want to containerize any application, the first thing that we should do is we need to write a Docker file for our application. So let's start writing the Docker file. So the Docker file name should be like this, D should be capital, and now inside this we need to write a set of instructions for the to build the image, right? So let's write. So the first instruction that we need to write is a from. Okay, that will specify what is the mini OS we want to use it, right? So let's use the mini OS of Ubuntu. We'll use a Ubuntu 2004 version, right? So we got the mini OS. Now on top of this mini OS we need Python to be installed because this is a Python application. So for that we'll use a run instruction and we'll do apt. First thing that we should always do when you are working with image, so we should always update it because these images are a little bit old, and if you want to get the latest version, so we have to make sure that we update it, right? So I'm just doing a apt update. Then if you want to run multiple command using run instruction, the separator should be $ampersand. Then let's try to install a Python. So apt install, let's install Python 3, and I'm using a -y option to specify that we don't want any user interaction here. So usually when you try to install any package on Ubuntu system, in between it asks for the confirmation. So just to avoid that interruption, I'm just adding -y option, right? Now we need also to install the Python package manager, that is pip, so that all the Python related dependency for this application we can install it, right? So let's install that as well. So we have a apt install, and then a package name is python 3 -pip. Okay, and here as well we also need to provide the -y option. So this will install a Python package manager, right? Then what next we need? The next thing that we required is to install the Flask, right? So how to install this? pip3 install Flask. So that's it. So now we are done with the mini OS as well as all the dependencies required for your application we have installed, right? The next thing is we have a copy instruction which will help us to copy our application code into any location, right? For example, let's say we copy our application code into the /opt directory, right? Now we got the code. The next thing we should do is we have to open the port where your application is running, because by default all the ports of your system will be closed, right? So we are using this Ubuntu 2004 image, so by default all the ports are closed. So if you want to open a port where your application is running, we have to use expose instruction, right? And we have seen in the app.py that our application is running on 8080. Okay, that is the reason I'm adding here 8080. And then at the end we need to specify or use a cmd instruction that will specify what is the first command that we want to run as soon as we start the container. So what command we want to run is Python 3 is a utility, and then our application we copied under /opt directory. Okay, so let's try to run that as well. So that's it. This is what we need to write it in the Docker file, where we have written some sequence of instruction. Once we are ready with this, what next we need to do is we need to build the image, right? So how we can find the Docker images? So we have a Docker images command. So you will find some images here that I have used for some other recording. So let me just remove that so that you will get to know what is happening. So to remove the images, we have a Docker RMI command. So let me just use those image IDs to delete this. Right, so I just specified all the image and I think we are done. So now if I do Docker images, okay, so there is still one left. So let me just try to remove that as well, docker rmi, and this is my image id. So this is also should go remote, right? So now if I run docker images, we are done. Perfect. So we deleted all the image. Now we want to build an image from our docker file, right? So what is the command? We have a command, docker build is a command. Okay, and then -t is to provide the tag to our image. So let's provide a name as training, okay, :1.0. This is what the name will specify. So training is an image name, :1.0 is the version we are providing. Okay, so if you don't provide, by default image version would be latest. Okay, so don't forget to provide it. So we'll provide it as a 1.0, right? And then at the end we have to specify the context or the current location of your docker file. So that is there in the current directory. So that's it. So if you run it, you can see it started building the image. So first thing that it is doing is it is pulling the Ubuntu 2004 image from the Docker Hub. So Docker Hub is a one public registry where all the public images are available. So out of that Ubuntu 2004 is one of that, right? So we got the image. Now we are trying to install a Python. Okay, then we'll try to install the Python package manager as well as we install the Flask, right? And you can observe also here that along with Python, it is installing some C++ related libraries as well. Why so? Because Python is created on top of C++. Okay, that's why it has to install the dependency as well, right? So let's wait for a few seconds to finish this installation. So once this installation is done, our image will be ready, and then we'll see how we can create the container out of it, right? So it's almost done. You can see after that it is just updating all the package list as well. So we'll see, once this is ready, we'll see how we can create the container. Okay, you can see it is installing a Flask, and at the end our image is ready. So if you do docker images, we have the image training 1.0 image is ready. Okay, you can see here Ubuntu 2004 it got pulled, which is just 72 MB, but our image is saying total 447 MB. Why so? Because on top of that 72 MB we have installed Python, we have installed Python package manager, we have installed Flask. Okay, so mainly to install a Python it has to install all the dependency related to C++, and that's the reason we got this much size. But still find around 500 MB is very decent size. Okay, so our image is ready. Now let's talk about how we can create a container from this, right? So to create a container, we have a command, docker run is a command. Okay, so docker run is a command. -d we have to use to run the container in the background mode. Then by using --name, we can specify the container name. Let's say I'm just using container name as a first. Then the next thing we should specify is a port. Okay, so why this port we need to specify? Because this container is running as a process inside your system, right? So obviously for a end user this process won't be visible, right? What would be visible is your system, right? So for that's the reason we'll bind the container port with your host machine port, so that if you try to access a host machine port, automatically the traffic will be sent to the container, right? So we need to first provide the host port. Let's provide it as a 8000, and then let's provide a container port where our application is running, so that is 8080, right? And then at the end finally we have to provide an image. Our image is training :1.0, right? So that's it, the command. Let me repeat: docker run is a command, -d is to run the containers in the background mode, -name is to provide the name to the container, and then -p is to provide the port binding, and at the end we are providing the image. So let's run it. Okay, so what it is saying is that okay, I think I messed up the spelling here. You can see it's a Python 3, the spelling mistake. So let me open the docker file, and here you can see I missed the Python spelling. So let me just correct it, Python 3, and let me save it. Once saved, now we modified the docker file, so we need to rebuild the image, right? So let me just do it quickly. So it's rebuilt. Now let me see if we missed anything. Let me just remove this container, docker rm first. So container is removed. Let's try to run it now. Okay, so you can see container got started. Let me do docker ps -a. So docker ps-a will show you both running as well as exited container. Okay, so now we have only one container, so it's a perfectly running, right? So how we can access this? We can access it using curl. So it's running on this system itself because we have done the binding. So I can, if I do localhost colon 8000, it will send a request to this EC2 instance 8000 port, and then in turn that EC2 instance internally will do the send the traffic to the container port. Okay, that is 8080, right? So if I run it, you can see we got the output from the application that hello from container world. Okay, so next thing is how we can see the logs of the container. We have a command docker logs and the container name, right? So if you run it, you can see this is the log of our application. So we started one web service which is running on 8080, and we hit this application once, so that's why this is the log, right? So if you go back and just run it again, now if you go back and see the log, you can see the second entry got added because this is the log, right? Now let's see how to log in inside the container. Okay, it's a very simple. We have a docker exec command. Docker exec is a command. Then we have to use -it to specify an interactive shell, okay, for our container first. And then there are different shell types are there, like bash shell, k shell, right? So which shell you want to open? So we want to open a bash shell, so that's why we specified here. So you can see prompt got changed, right? Earlier it was EC2 instance prompt, but now this is a container, right? So you can see even container ID like b4 bed, right? So if you scroll up, this is a container ID b4 bed, right? So now we are inside the container. Now if you remember, we copied our code under /opt directory, right? So if I do ls here under opt, you can see our app.py is here, right? So that means we are inside the container. So how to exit out of the container? So for that, exit command we can use, right? So now there is another very good command we have from the docker is, if you want to see the all the compute resource usage by this particular container, we have a docker stats command. Okay, if you run the docker stats command, it will show you the all the compute resource usage by this container. Okay, you can see it's just using around 0.12 of CPU. It is using 37 MB of RAM out of 1 GB. That means it's just around 4%. This much network IO is happening, this much block IOs are happening. So all this information you will be able to see, right? So if you really want to benchmark your application with older changes and new changes, so this is something that will help you to benchmark your application. Like let's say you have developed an application and you are checking how much compute resources it is using. If it is a very high, just you can take this information and then you can just improvise, optimize your code, and then again you can run it and again you can check this. So you will get to know that how much improvisation happened in your application, right? So this is a very important command we'll get to know, right? So now we have seen how we can build an image, how we can create a container out of it. What next we want is, now let's say you want to push this image to the Docker hub, right? So yesterday we talked about like how overall architecture of Docker, right, where we build the image. If you want to use there itself, you can just start the container, and when you want to share that image with someone, we need to push that to the registry, right? But now uh, we have to either push it to the private or public registries, right? So we are using this is for training, so we'll use the public registry. So let me show you how it looks like. So basically we have one website called hub.docker.com, right? So this is how your website will look like. So I'm already logged in inside this. So this is the this is how it will look like. So now we wanted to push our image. So for that I have already created an account. I have this particular Docker ID. So what we can do is we have to tag our image with that Docker ID, right? So how to do that? So for now, if you see the image, we have the image with a name training, right? But if you want to push to my Docker ID, that is Rajendra IT99, we have to tag our image with that Docker ID, right? So how to do that? Docker tag, then what is the image you want to tag, that is training colon 1.0, and how you want to tag this, you want to tag with my Docker ID, that is Rajendra IT99 slash, you can provide any name here as well, let's keep the same, and the version, right? So if you run it, the tagging is done. So if you closely look here, it is just creating an alias, nothing else. Okay, it is not creating a completely new image. So it's a kind of like two variables pointing to the same memory location. It's that kind of a syntax. Okay, so it's just creating alias. So we created an image. Sorry, we tagged it with our Docker ID. Then now what next we need to do is we need to authenticate ourselves with that particular Docker ID, right? So for that we need to use a Docker login command. So when we run a Docker login command, it will ask you the username and password. Okay, so whatever username and password you used to create an account on that Docker Hub, exactly that you need to provide here. Okay, so I already logged in, that's why it has not asked me to again provide that detail. But when you do it for the first time and run the Docker login command, it will ask your Docker ID and the password of that you used while login into your Docker Hub account, right? So I'm login succeeded. Now I can push the image now. So what I can do, Docker push and then the image, right? What is our image name? Rajendra IT 99 is my Docker ID, and our image name is training colon 1.0, right? So if I run it, you can see it will start pushing that image. Okay, and within a few seconds that image will be available on a Docker Hub. So let it finish and then I'll show you on the Docker Hub that particular image is available remotely. So let's wait for a few seconds to finish the push here. So it is almost done. Overall it is around 360 MB, that the one large layer. So that's almost done now. So once this is done, we can go back and see our image on the Docker Hub. So that is a network storage, or we can call it as a public registry. So pushing is done. Let's come back and let me just refresh this. So if you just refresh this page, you will see here that Rajendra IT 99/training image got pushed for few seconds ago. So you can see the tag that we have used, right? So that means we got this image here. So right now this is a public image. If you want to make it private, go to the setting and you can click on this make private option here, right? So we are just creating it for learning purpose, so definitely we don't need to make it private, but that's fine. Now anybody who wants to use this image, they have to just use docker pull Rajendra IT 99/training colon 1.0, right? So if you want to quickly see that, what we can do is let's go back, and what I'll do is I'll just first show you how you can stop the container. So if you want to remove the container, first you need to stop it. Okay, docker stop and then container name, right? So we first stop that particular container. Now we can remove it, docker rm and the container name, right? So now container got also removed. So now let me show you how we can remove the images. So docker images, here we have a few images. So if you want to remove the images, we have to docker use the command docker rmi, and then you can use the image id, right? So let's use it. It is not allowing to do it. Let's do it forcefully. So that's done it now. Let's delete other images as well, docker rmi, and I'll use this other two IDs as well. Let's use the -f so to do it. So that's it. Now all the images are deleted. So now how you can pull it? So let's consider I don't have, this is a completely a new environment where I want to pull that image. So what I can do, that's a public image, so simply I can do docker pull the docker ID from where we want to pull it, and then the image name like training colon 1.0, right? So if you do it, it should be able to pull that image. So you can see it is pulling. Let's wait for to finish the pull. It's almost done now, right? So pulling is done. You can see docker images, and we got the image. So now if you want to start the container, the process will remain same. Let me just quickly show you. Docker run -d is to run it in the background. Just provide the name to the container. Let's say I'll just provide it to second, and then you can provide the port binding. Let's again use the similar port 8080, and then we need to provide the image name. So this is our image name colon 1.0, right? So let's run it. So container started running, docker ps container is running. How we can access? Curl localhost colon 8000 and that's it. We are able to access the application, right? So this is how it's a very simple to operate with a Docker. It's a very straight. So we have covered every basic operation that is required to know to containerize any application. So I hope everyone liked this video. So don't forget to like and subscribe the channel, as well as share with your circle. Okay, and make sure everyone is understanding. And if you have any doubt in this video, just put it in a comment. I'll just try to reply as soon as possible. And if you have any specific topic that you want to learn and you want to get that video, just comment it. I'll make sure that I'll create the video for that. Okay, so thanks everyone.